So now in the last video we saw the exploratory data analysis, and then we fixed the fix the different components of a state. Now let's look at the overall, how the complete solution would look like. Now the process starts with from a customer context. So a customer logs in, and then there is a context which is extracted from the customer. Now the context involves the segment in which the customer belongs to, which month is the customer coming in, which period of the month, which day of the week, because these are the states which we decided. These are the components of the states which we decided. Now in an ideal system, all these things could be extracted from the month, the date and the day of the week. These could be extracted from the system time itself, that is, and when the customer logs in, the segment of the customer would also be automatically captured. Now one big change which we are going to make is, because we don't have a real system, we don't have real customers, but so what we will do here is we will simulate these actions. That is, we'll simulate the creation of a segment, month, the day, date and day of week. This is not data, this is date greater than 15. So and the day of the week. So which we will first simulate the state in which it comes. So from an implementation perspective. Now if you want to implement this in a real system where real customers comes in, obviously you need to capture these details as and when the customer logs in. Now based on the state, the agent, which is here is a bandit or reinforcement, or the recommendation system is a bandit, or which is our agent. The bandit has got a certain value functions and a reward functions. Now you have seen that in the bandit exercise in the post 2. So wherein where each arms has got a certain value functions. So similarly, here the different arms or the different levers are the different products which you recommend at a certain point of time, and each product will have a value function for that particular state. Now what do we get these value functions and reward functions? And these are initialized, in the beginning they initialized using the historical data which we have. That online retail set which we have extracted will be used to initialize this value function, reward function. So that in our first part of the next post, we would be talking about how do you initialize these value functions and reward functions, and sorry, we'll be talking about in the second prototype, wherein we initialize these value functions and reward functions. In the next post we will be talking about how do you segment this. How do you segment different customers, because from the data set. So that is what you can expect in the next post. And the post after that, we will talk about how these value functions and reward functions are extracted from the data. Now this value functions and reward functions would form the kind of the heart of your agent, because that's the basis on which you take your actions, and your actions are the different recommendations which you give. Now from the K-bandit perspective, these are your different levers, lever 1 to lever 10. So your objective is to give maximize the reward for each lever. Find those levers which will give the maximum reward, or in the sense that which is appealing to the customer. So your actions are to recommend these products. Now once the products are recommended, then it is time for the customer to act on it. Different products have been recommended to him, and the customer can take actions on these products. So the different actions the customer can take is, the customer can buy a product, or you can browse through a product, and customer can ignore the products which has been recommended. Now these are your customer actions, and based on these or customer feedback for the channel, because we are taking actions or the act of recommending products is our actions, and these are your feedback from the customers: buying, browsing, and or ignoring products. Whatever is not bought or browsed through, will obviously be ignored. So why buying is very obvious. Yeah, that shows an affinity. Why browsing? Because browsing would show a certain bit of affinity, that is, it means that the customer could be interested in that. So we have different types of rewards. Even though these both are positive rewards, we'll have different quantum of rewards for each of them. Say for example, buying will have a positive reward of 5, or browsing will have a positive reward of say 1, and ignoring a product will have a penalty or a negative reward of say -2. So that's the way the feedback goes. Now these are the feedbacks. Again, from an implementation perspective, we don't have a system where customer gives a feedback. So again, we'll be simulating this. That is, we will simulate this, whether the customer has bought, or what the customer has bought, or what the customer has browsed, and what is it that is ignored. So this will again be simulated in the later post, in post 6. And based on this feedback, the updation of the value functions happens. We saw that in the when we discussed about the K-Bandit also, how the value functions get updated. That old estimate or new estimate is old estimate plus step size into reward minus the old estimate. So that formula, the simple averaging formula, could be used. Now this is another area where you can also improvise upon this. Now we have, in this post, we are just using a simple averaging method. Maybe you can go for mean averaging method, or any other types of methods which we can use. So that's up to you, to your ingenuity, to try out different types of things. So this is the overall context in which we will do all our code, all our prototyping, all the scripts which we will develop in the future post will be based on this big picture. So always have this big picture in mind, so that you will be clear in these subsequent posts.